So in order to make our arena simulation, the first step was to build a balustrade map. As you can see, we have the section building, the unit building, and the final assembly. Since both cells work the same, we only need one for both. One thing that we noticed here was the monthly express all of the suppliers, and we put the cycle times in order to know, and it's really surprising that the value at the time is 7.75 hours compared with the whole time that was 4 weeks, and that's the main reason why the demand was not made on time. So after that, this is kind of just an overview of the change we made. We're going to explain each of them later. So the big problem was the amount of work in process, which represent a net loss around of 3 million a year. With the first change we made was the layout. We combined both cell G and A in just one big cell, changing the final assembly from cell A to the place where all the assembly was for cell G. We changed from a push system to a pull system. We applied 5 LTB and included a negotiation with the supplier and changes for the engineering, which represented a big downtime before the units going into the process of building. This is what we expected to get after applying our changes. That's the future map. We tried to get the supplies every week instead of every month. One of the big things was that if a part was missing, it could take from days to weeks to get to the plant. So it represented a bad negotiation with the suppliers. That's why we changed it for a week. We combined all the workers from cell G and A and distributed into different steps. As you can see now, are more than double in different units. And as you can see, we have a full system. So the first change was the plant layout. As you can see, here was the final assembly for cell A. Now we have large lines for unit building, and we have over here we have cell G. Now it's the final assembly there. For this, we're assuming that there's no transportation implied there, and we don't have the transportation cost for it. I'll tell you that we changed the workers. I'm going to show you the new relocation of them. The first thing was to double the workers in every step of the process and run the simulation. After that, we saw the percentage of value at the time of the workers, and based on that, we relocate. In some steps, we needed less workers than we had, and in others, we needed more. So the final thing is, as you can see there, one of the main changes was for section build step 5. We passed from one original worker to 8. There were a lot of work involved in that step.
Alright, so originally they had a FIFO push system set up, and FIFO is first in, first out. And a push system is just as you're building, materials keep getting passed to you as you're building, so you start getting a lot of buildup if you're taking a long time to do that. So we changed this to a Kanban pull system, so that way as you're building, you don't have the stack of materials. Once you're done, you pass it along, and you get stuff from downstream to you, and that way you don't have your huge buildup of materials right there. We also set up a 5S event. 5S is all Japanese, but translated, it stands for sort, set in order, shine, standardize, and sustain. And we had noticed that in the data they had given us, there was a lot of times where the parts were either unclean, missing, or incorrect. I think they gave us 16 weeks of data that was actually real data, and there was a couple of weeks where the percentages was as high as like 80% or something like that. So we thought if we put in a 5S event, the percentage of these mishaps would be able to be reduced. So that way we would reduce the non-value added time of waiting for the parts or cleaning them or whatever. As Gabby said, we also noticed that the time it took if a part was missing to get from the suppliers back to us was up to a month. So we figured if we could negotiate with our suppliers and try and get a weekly delivery time, that would also reduce the amount of waiting time for that part. Also, we had engineering changes that had to take place in the unit build. This was before it actually went out into production, and we noticed a lot of fill-up work in process there. And we assumed that this time to do this engineering changeover was due mostly to the fact that the engineers weren't familiar with the computer design of the parts and stuff, so that was what was taking most of the amount of time. So we figured if we hired a software engineer specialist, they could come in and the time it took for this engineering changeover would be greatly reduced. That's all our changes. Now if we're gonna, now we can show you our actual thing. Alright, so this is our whole thing. Really small. But I'm going to run it for a little. I'm not going to run the whole thing because it takes like 20 to 30 minutes to actually run the whole thing. But if we just zoom in on one section. You can see the parts are being created over there, and then we had all these things. It checks if the parts are all there and present and stuff. And it also checks to see if all the parts are correct and stuff. So those were the percentages we were given. So this is where the 5S event helped. So we don't get nearly as many down in here, and it can continue on. And then over here is where the section build starts. So